Hello and welcome to Physics with Fabs. That's me. I'm your host, your teacher, Mr. Fabianski. At least that's what the ID says. And today we're going to talk about the kinematic equations of physics. Now there's three kinematic equations. All right, the kinematic equations. This all has to do with acceleration. Now, earlier, we've learned some very special equations that we keep near and dear to our heart. We've learned equations like dirt, D equals RT. We've learned equations like X equals VT, okay? Both of these equations we deal with when we're talking about constant velocity, okay? These deal with constant velocity. Now, there's a change. We need to start talking about acceleration. We've learned about acceleration, right? Acceleration is a vector. It has magnitude and direction. We can get the acceleration from calculating the slope of a velocity versus time graph. Acceleration can be both positive and negative. So we've learned all of this stuff about acceleration, but we haven't yet learned how to plug it into an equation. Well, that is what today is all about. Learning how to put acceleration into an equation. Because see, we've just done calculations on constant velocity, and in a perfect world, that's great, but the world's not perfect, right? We do have velocities that change. We experience motion in which there is an acceleration. And that's what we're going to be going over today. Now, it's not that bad. It's only about a page and a half. It'll go pretty quick. I feel like I've already said that. Of course, this is like my third time of trying this video, so if I said it in this video, sorry. If I said it in the other videos, you haven't really seen those, so that's okay. But anyway, nothing else, you get a good laugh. So let's start with this stuff, okay? Kinematic equations. So we've talked about displacement. And what displacement is, sorry about that glare, guys. What displacement is, there we go. Displacement is simply a change in position, right? From the final to the initial. The path doesn't matter. It's just the final to the initial. A change in position. And then we talked about velocity. And what velocity is a change in position or a displacement over a time period. And then last class, we just talked about acceleration. And we said acceleration is actually a change in velocity over a time period. So we have, we have this relationship. We can go from displacement and use displacement to find velocity. We can go from velocity and use velocity to find acceleration. We have this motion right through. And remember, they're all vectors. They all have magnitude and direction. Okay? We can use these three to determine the kinematic equations. Okay? Make sure you got that. If you didn't get it written down, pause the video, because I'm going to erase it as we speak. Hopefully you paused that video. If you didn't, just rewind it. Pause it then. All right. So we need to remember the units. Displacement's units. Displacement, the unit is the meter. Velocity, the unit is the meter per second. Acceleration, the unit is the meter per second squared, and these will always be the case. It'll always be a length per time squared. Now you may see kilometers, you may see kilometers per hour, but it'll always be in that ratio, in that fashion, okay? So very, very, very important. All right, so we are going to start deriving these equations. Now, I apologize ahead of time. Derivations are never, ever fun, but it'll make you a better person for going through them. And if you don't believe me, I don't even believe me, so I'm sorry for that. But you do need to see them, so just bear with me. Write this stuff down. We'll go through it pretty quick. So this will be for equation number 1. Can you guys see that up there? All right, I got this this area right here. I'll try and skip that out. So for equation number 1, we know that the acceleration equals a change in velocity. Acceleration equals a change in velocity over time. All right, change in velocity over time. I promise if I do more of these videos, I'll get like a shade or something for that light right there. That way the glare isn't too bad. We have a change in velocity over time. That's what acceleration equals. From there, a change in velocity is really just the final velocity minus the initial velocity over time. We could rearrange this in such a way, we'll bring that t up there, we'll multiply it. We can rearrange this in such a way, a times t minus vi, that we get an equation. So we're going to rearrange this equation and get this. Vf equals vi plus at. That right there is our first kinematic equation. Now there's only 3. All right, that is our first kinematic equation. All right, hopefully you got that. I'm going to erase this. Don't worry, I will write the kinematic equations over again. But we've already got one down. Let's move to our second kinematic equation. Let's see. 2. All right. So let's start off again. Velocity now equals a change in position over a time, which means a final position minus an initial position over time. We can rearrange Vt equals x final minus x initial. All I did was I brought that t back up, I multiplied by time. Now, this velocity, we're going to rearrange this one more time. We're going to switch. We're going to bring the Vf over and the velocity times time over to there. So we get xf. I'm sorry, we're going to bring the xf over. My bad. xf equals xi plus vt. This velocity right here is the average velocity. And anytime you find an average, you add 2 values up and divide by 2. You add 3 values up, you divide by 3. You add the values and you divide by the number of values. Well, in this case, we're going to be taking the starting velocity and the ending velocity. Okay, so let's see. xf equals xi plus the average velocity now, vi plus vf over 2. That's an average. We added 2 values and divided by 2 times t, because we can't forget that t. All right, remember equation number 1. Equation number 1 was this. Put a little 1 there for equation number 1. It was Vf equals Vi plus At. Well, guess what? We're going to take this equation and we're going to plug it down into the Vf. All right, that's going to leave us with something now that's a little bit more cumbersome, we'll say. Xf equals Xi plus Vi plus Vi plus At over 2 times t. If you're shaking your head right now saying, Mr. F, what are you doing, Fabs? Come on. I don't want to remember this. What are you doing to me? I'm saying just trust me. Just trust me. Hold on for 1 second and trust me. It'll be a little more than 1 second, sorry. But trust me. Okay, from here we can distribute all of this fun stuff and we can write this. Xf equals Xi plus Vit plus 1/2 A t squared. From here, we can do one more movement. One more movement. We're going to bring this guy over, and we're going to get the displacement. Because what we did was we subtracted the initial position. So we're looking at a change in position, which is just displacement. D equals VIT plus 1/2 a t squared. And guess what, guys? That is our second major equation. So now we have two. We have two done, only one more to go. Number one was right here. Number two. We're almost there, guys. Almost there. Okay? So let me erase this, and we'll do the last one. Look at that. We're already done with page number one. This is all we have left. It's a little bit. All right, for number three, we're actually going to pick up at a different spot that we covered in number one. So for equation number three, we're going to pick up from this spot. If you look back to your notes, you'll see that we were here when we were calculating, or when we were deriving equation number two. So we're going to now deviate from the original path we took and take a different one. All right, so according to this equation, we can now make a substitution. And the substitution will be as follows. We know that the acceleration is a change in velocity over time. We can rearrange this to go time equals a change in velocity over acceleration, and then we can plug that time in. All right, so x final equals x initial plus VI plus VF over 2 times, now we're plugging this in, the change in velocity is just the final minus the initial over the acceleration. I know you've seen these before. We have to multiply those out. I'm just going to give you the abbreviated version. Don't worry. XF equals XI plus VF squared minus VI squared over 2A. Now we solve for the VF squared, and we get this very nice equation plus 2A times displacement. And that is our third and final equation. So remember, make sure you get this done. Remember, I told you to trust me. You gotta trust me. That's why we doing this. Come on, Mr. F. There's no way I'm gonna remember this. And number one, I'd say, yes, there is a way you remember it. If you keep on going over it and you understand each single step what we did, you'll definitely understand it. But remember when I told you to trust me? I said, trust me, right? Trust me. Well, here's the good part. You don't have to remember those derivations, okay? They're important because I wanted you to see where these three equations come from. You need to know that we just didn't pull them out of thin air, okay? They are important. Yeah. They weren't just made up somewhere, right? Someone actually put in the time to do the derivation and to make our life easier. So these three equations, they will be on the board over there, right? The rolling board that has all the physics equations on there, they will be there. You will not have to memorize them. Although I promise you, the more you use them, the more you will memorize them, essentially, okay? Now, make sure you understand that these three equations all deal with motion that has acceleration, either positive or negative acceleration. Okay, positive or negative acceleration. If you have constant motion, you wipe these out. You're doing D equals RT, you're doing X equals VT. But if there's a hint, a car accelerated, what is your acceleration? A car decelerated, a car experienced negative acceleration. You're using one of these three equations. I promise you that. I promise you that. Okay? So just quick to make sure we understand what these variables are. Anywhere you see a VI, VI is the initial velocity. VF, what do you think that is? Good job. It's the final velocity. A is the acceleration. D is the displacement. And T is the time. So when you're going over these equations or you're reading problems and it says, how far did they go? They're looking for displacement. How long did it take them? It's time. What velocity did they end at? Final. What was their starting velocity? Initial. What was their acceleration? Acceleration, right? It's a nice one. So these are your three equations. These are what the variables stand for, and this is when we're dealing with accelerated motion. All right, guys, now I would like you to complete, among other things, a quick little kinematic type practice sheet. I'm actually going to do the first problem with you guys here in this video, and then the other problems you'll be on your own, but you always have to follow the same general rule that we're going to follow when doing these problems. So if you give me 2 seconds, I'm going to grab that problem. I'm going to tell you where it is, and then we're going to work through it, and then that'll be it for this video. So 2 seconds. All right, I'm going to keep these equations up here. That way we can look at them quick. I'm going to read you the problem. You also have the problem in your class notebook. Under Unit 1, it is the Kinematics number 1 problem set. It has 3 problems, and it looks just like that, 3 problems. So problem number 1 states, a certain car is capable of accelerating at a rate of 0.6 meters per second squared. So right away, if the car is accelerating, we're dealing with one of these 3 equations. How long does it take? How long? That's time. How long does it take for the car to go from a speed of 25 meters per second to 27 meters per second? All right. Let's see what we can do. When approaching these problems, it is extremely important that you follow some rules. And the worst rule. The first rule you should always follow, this is number 1 on the problem set. The first rule you should always follow is make a list of what you have and what you're looking for. According to this problem, I know I have an acceleration, an A, that is 0.6 meters per second squared. I know I'm looking for a time. How long did it take? So for time, I'm going to put question mark. And then it says, how long did it take to go from a speed of 25 meters per second to a speed of 27 meters per second? Those are my 2 velocities. It's my initial and my final. So my initial velocity was the 25 meters per second, and the final velocity was the 27 meters per second. All right. The next thing you want to do once you've made your list of all the variables you have and the variable that you're looking for, there we go, I feel like a weather person again. You want to look to your equations and see which one you can use. The best way to do this is simply look at all your variables and find the equation that involves all those variables. I have an A, a T, a VI, and a VF. An A, a T, a VI, and a VF. Can I use the third one? There's a VF. Yeah, that's good. It's a VI. Good. There's an A. Great. There, I don't have that. Can't use this equation. Let's look at the next one. I don't have that. But I do have a VI. Oh, I don't have that either. 2 variables. Want to stay away from that. I have a VF. I have a VI. I have an A. And I'm looking for a T. Perfect. That is the equation that I want to use. So I'm going to use the first equation for this. VF equals VI plus AT. And then you're just going to plug the numbers in. VF is 27. VI is 25. A is 0.6. And T is just T. It's still a variable that we're looking to solve for. Remember, we want to get T alone, so we're doing everything in reverse. Normally, the last thing you do to solve the problem is add that. We have to do that in reverse, so we have to subtract that. Subtract 25. That gives us 2 equals 0.6t. Now we simply divide, and we get t as equaling 3.33 seconds. Do not forget those units. Very important. All right. Units for time, seconds. Units for length or displacement, meters. Units for velocity, meters per second. Acceleration, meters per second squared. Do not forget the units. It is extremely, extremely important. And that's it, guys. You're using your kinematic equations to solve for motion that has an acceleration. One other thing that I want to make you very aware of. I wouldn't suggest using the second equation to solve for t. Why? Take a look. Here's the variable t. Here's the variable t. If you're using this equation to solve for time, you're essentially going to be solving a quadratic equation. And those just aren't fun. Physics is very fun, but solving for quadratics, not so fun. So what I would suggest you do is try to use the other equations to solve for time, mainly this one. Always remember to square the velocities for equation number 3. In equation number 2, only the time is squared, not the a, not the 1/2, only the time. All right. Hopefully you guys have understand this. Hopefully you guys follow this. If there's any questions, please, guys, email me, send me a chat on Teams. Get the remainder of this sheet completed along with an additional practice, and I will see you guys next time you're in class. All right, this is Mr. F saying thank you for spending the past 22 minutes and 10 seconds with me. I very much appreciate it. Guys, have a wonderful weekend. Have a wonderful rest of your day, and I will see you all in class. Take care, everybody. Mr. F saying see ya. But seriously, bye, guys.